Recording. Welcome
Yeah,
back to the.
how did yesterday go? Sorry, I wasn't able to make it.
That's okay. Yeah. Well. First and foremost, welcome back everybody for the last day of Intro to Coding. This is day 9. Um, Yesterday, to answer your question, David, we were reviewing or we covered Mini Project 2. Mini Project 2 was the Powerball. After today, if you get a chance, I highly recommend you review the Mini Project 2. I think Tamika, and Dante, Andrew, Monica, y'all can probably attest to it that Project 2 was a was really good. It's a good one, right? There's a lot of good stuff to take away from that project. So definitely review that video. Um, from the code that I saw from you guys, and then if you were to compare your code to the final product that I was able to come up with, like you can see the difference. Like, oh dang, like I was kind of kind of off. So it is a nice little eye opener, and it can introduce you to new concepts and how to really apply the tools that you've been given into an exercise, right? Um, and really, that's kind of the main thing to take away from these projects is because the biggest issue or the biggest concern I get or question or comment is that uh, I have the tools, right? I've been through the videos, I've been through the lessons, I practice every day, but once I get behind the exercise, I lose you know, my train of thought, or I don't know how to apply everything, right? I don't know how I can use everything I've learned to solve this question. So these mini projects kind of really help you uh, try it out. And today we're gonna go and do another mini project, which is gonna be our last one, which is gonna be poker, right? And just like yesterday, we're gonna go ahead and talk about the mini project. This is a typo. It says mini project 2. They should say mini project 3. I always forget about it until I teach this class. But this should be mini project 3. And just like yesterday, we're going to talk about the problem, right? We'll dissect what it's asking of us, and then we will do some pseudocode, right, where we can write out in comments how we might approach this, and then we'll break off into teams, into individual groups, where we can collaborate with each other. We'll come back around 8 p.m. to 8:15, where I'll do a walkthrough of the code. If anybody finishes before that time frame, then I might have you present as well, to show your result. We can compare and contrast code to see, difference between them. Um, and yeah, so without wasting any more time, let's go ahead and jump straight into it. So this is gonna be our very last assignment, our last project here, um, and we're gonna be using Python to replicate poker. Now, it won't be exactly like poker, right? If you are a poker fan and you like to play this game, you might be like, "Oh, this is not poker." That's fine, right? We're not replicating poker exactly, but we're replicating a little bit of that functionality. All right. For those of you that don't play poker, and me being one of them, I'm not a big poker fan. Mainly because I can't bluff. I'll just start smiling and laughing at you if I look like I'm winning. So I don't play poker. But poker is a game that comes in various forms. It is a card game played with two or more people. For this scenario, we're going to be using just two people. If you want to expand upon this project, you can definitely add more players and try to replicate poker as best as possible. The maximum player count is determined by the type of poker game. The way the cards are dealt can vary wildly, but the base concept is the same, right? A player wants to get the best five card hand possible, right? And win the chips in the middle that have been bet. So really, you should have a certain amount of players, right? At least two, that can play against each other. They're each going to have a hand. A hand is going to consist of five different cards, right? And you should already start thinking like, how can I recreate two different hands, right? And you can kind of take away a little bit from yesterday's assignment with the lottery ticket of how you could probably do a hand in poker, right? Yesterday we created a lottery ticket using dictionaries, right? We had key value pairs. The white balls had their own key value pair, and then there was a red ball that had its own key value pair. That represented a ticket. We could probably do something very similar like that, with a hand, right? Each player should have their own hand, there should be five cards in that hand, so five different values, right? So you should start thinking like, what data structure could I possibly use to fit this scenario? Would I want to use a list? Do I want to use a set? Would it make more sense to do a dictionary for the key value pair? What should it look like? There are many factors that drive poker gameplay, such as bluffing, but there's always one final comparison that determines a winner of a hand, which is the showdown. The showdown is where the players that have not folded compare their hands to each other to find a winner, right? This image is a little blurry, so let's go ahead and open up Google. And my pizza's here. Oh, they gotta break some. Go ahead and do poker uh hand rankings. And we'll use this one because this is the one that's in the assignments. Uh, let's go ahead and we'll do open image in a new tab. And there we go. I believe this is the one in the assignment. It's similar. But these are the rankings. And just like yesterday, we use the picture from the Powerball. We'll just use some external sources to ensure that we understand how poker is played. But here are the poker hand rankings. We have the best possible hand, which will be your royal flush. A royal flush consists of all the what's it called, the ace, the king, the queen, the jack, and the
Face
10, right?
cards.
The face cards. Thank you, Todd. I bet you gamble. But it's gonna be all your face cards, right? It's gonna be the highest number, which is gonna be 10, followed by the face cards from jack, queen, king, and then finally the ace. Right? This is gonna be your royal flush. Uh, Next we have the straight flush, which is a little similar to the royal flush, right? Uh, Notice that the numbers are 6, 7, 8, and 9, right? So they are in sequential order, right? From lowest to highest, but they're all the same. I believe it's called suit, right? They're all the same suit. So um, whether it's all diamonds, whether it's all spades, all clubs, but to be all the same suits, right? What were to happen if there's two people with a straight flush, right? They had five cards with the same suit. Well, how will we determine who's the winner? Well, you would take the number values of the cards, right? In my straight flush goes from 6 to 10, but Todd's straight flush goes from 3 to 7, I think. That 3, 4, 5, 6, 7. Yes, 7. Quick maths. Then I would win, right? Because my numbers are a lot higher than his numbers. Um, the next one here's the four of the kind, where it is at least four of the cards out of the five cards that you have should have the same number, and they should all be their own individual suits, right? And then we move downwards, and you can kind of use these charts to identify the rankings of the cards, right? If you want me to review these, I could, but notice that some of these are grayed out, right? Four of a kind, it only takes four, which is why the fifth one doesn't matter. Three of a kind, it takes three, so the other two are grayed out, right? So a three of a kind would be if your hand has three cards of the same number. Two pairs, two cards that have the same number or the face, but not the same suits, you know. Or I think the suits doesn't really matter. Really, just having the two cards here for two types, and so on and so forth. So here are poker hand rankings. We're gonna want to ensure that we are able to replicate this in our mini project, right? So how will we compare between poker hand rankings? Well, we kind of already know we could use comparison operators, right? And we could use if else statements. All right. So let's do some pseudocode. Let's talk about the overall flow of the game, first and foremost. The first thing is actually someone start us off. What do you think we need?
To create a deck.
Yeah, I was gonna say, so
Deck of
question,
cards.
are cards getting dealt to the table, or are we simulating that basically each player's gonna be dealt five hands and then we're gonna compare those two hands or five cards for a hand?
Right. You're both right. Right. Well, we don't have a native poker hand method in Python, right? Python doesn't know what a spade is, right? So we probably first and foremost want to ensure that we are able to replicate a deck. So we want to create a deck, right? A deck is 52 cards. There are 4 suits. Is that what's called? Is it suits?
Yeah.
4 suits. The numbers range from 2 to 10. There is a jack, a queen, a king, and an ace. Right? For each suit, each suit has their own numerical value from 2 to 10. Its own jack, queen, king, and ace. Right? So, with that in mind, this should be 9 cards, 10, 11, 12, 13 per suit. I'm pretty sure I'm on something here. It should be 13 per suit. Quick maths, not today. 13 times.
Yeah, you're right. It's 13 pursuit.
Okay. I was trying to just show the math because I suck at math. 52. Yeah, there we go. Right. So 13 per suit for a total of 52 cards. Right. So with this in mind, we want to create a deck. Once the deck is created, we probably want to deal cards to our players. Let's go ahead and start with only 2 players. Right? One will be the computer, and then one can be you guys. Or actually, it really doesn't matter. We just need to be able to compare cards. Because you can't choose your card, they're going to be dealt to you. So it doesn't really matter who's a user, because really you can't even choose. There has to be dealt to you. Right? Deal cards to our players. So we might want to create a function to deal a hand. Right? A hand is 5 cards and should not have duplicates. Right? There shouldn't be 2, 5 of spades. Right? That doesn't exist. Once we deal our cards to our players, we should, at a minimum, be able to compare hands and identify a winner. And comparing our hands, we need to a subtask for this here will be check rankings. Now, there's some issues that you might come into with checking the rankings. It's going to be some difficult logic. I think the hardest part here will probably be create a deck and checking the rankings. But really, that's the entire flow of our game, right? We need to make sure that we can create a deck, issue cards, compare the cards, and determine who wins. Right? That's it. At a bare minimum, that's all we need. Now, if we were able to get through this and you guys complete this, stretch goal, add multiple players, add a pot. We can also do something like rounds. So add rounds. I think at the start of the game, each player gets 2 cards, right? So like I think round 1, and stop me, correct me any moment. Round 1, players get 2 cards. Then each round, I think the dealer draws cards and they puts in the center. Is this correct? Right? Everyone has their own cards.
Depends on what version of the game you're playing. If you're playing
Okay.
that, it'd be like, yeah, you get one to the center and then one on the flop.
Okay. Let's say Texas Hold'em. I think that from what I hear, that's the most popular one. But if you would like to do this, you can absolutely expand upon this. This is definitely doable. This is a very common high school like coding competition task. So have fun with it. I see people say that like what? Yeah. This is a very common project for like high school coders and stuff. Um, or like small like level hackathons, right? But yeah, so this should be the overall flow. Um, if you have any questions, I will be bouncing around to answer any questions, right? If you need me in your room, raise your hand as well. I think you can call me to the room and it will give me a notification. If I don't come to you immediately, I might be busy with a student. If you see me hovering in your room and you're lost, ask questions, right? Don't just wait like an hour just like trying to solve one concept and you're struggling. Like ask questions. Like I'm there. If I'm just hovering on the wall, like definitely ask questions. I'm watching to see what you guys are doing to see where I can provide feedback. But if you are struggling, like please, I'm here for you guys. Like this is my job. This is what I do for you guys. Like take advantage of the fact that I'm here for y'all. So let's see. Any questions? All right, no questions here. Um, for those of you that want to see yesterday's code, I highly recommend you check it out. I think I already deleted it from here. Check out the recording. Um, it should help you guys out. But without further ado, let's go ahead and open up some breakout rooms. We are 12 people. We'll take 3 to a room, so we'll do 4 people. I see link drop. Yeah, I believe I already dropped it earlier, but I'll do it again just in case. Please fill out the attendance, especially today, so we know how many people showed up the last day. It just helps us for like data tracking and whatnot. Really gives an idea of like how successful the course may be, or retention rates, to see how we can better improve. So please fill out the attendance form, and we're going to pause the recording.
Done.
Thank you. You are absolutely correct. Thank you for correcting me, Andrew. Appreciate it. So welcome back, everybody. We're gonna go ahead and go over the poker video or poker exercise. As I do this, I was mentioned before, I might make some mistakes. I don't have any accurate key, right? I teach this class 3 times a year, so I only see this exercise 3 times a year. And every single time I do it from scratch, right? So you might see a different video, it might be a little bit different. Um, but if you see anything that I may miss, right, whether it be syntax, whether it be flow, or maybe if I'm getting confused with all my code, kind of guide me back as the passengers and the navigators, and we'll make this work. So I had some code earlier, but I started deleting stuff because people were asking questions, and I was writing some code here. So I don't have the pseudocode from earlier in the class. So let's go ahead and start from scratch. I do remember the first thing was to create a deck. Python doesn't have any understanding of what a poker deck looks like, so we have to create that ourselves. So I'm gonna create a list of nums. Actually, I probably don't even need list of nums. What I really need is gonna be suits. So I can say something like suits is equal to, and I want to create. I could hard code every single card in a deck. I think there's much more
Ooh, don't
that,
do that.
yeah, much more important, much more efficient ways of not doing, to avoid that. So let's go ahead. We'll do a list of suits that we can use to iterate through, to create our card. So we'll say, I know we have spades. I'll just use initials. We have clubs, so we'll say C. We have hearts, so we'll say H. And actually, we'll use capitalization because that's a little bit nicer. So spades, clubs, hearts, and what's the other one? Spades, club, hearts, diamonds. Right. So these are kind of like the suits of our cards. And then what else am I missing?
Values, numbers.
Ranks.
Ranks, right? Ranks, it's just gonna be from 2 to what was it, 13, 10,
14.
11, 12, 13 to 13. Am I
Ace.
right? Ace, yeah,
Ace.
2, 10, Jack, 11, Queen, 12. You're right. Why do I doubt you, David? Um, so let's
Because I
go ahead
didn't
and
finish.
say, we'll say X. How do I do this? I don't use this often. X for X in range of 1, so 2 to 14. I think is what I can do. Current ranks. I don't do this often, so I might have messed it up. 15. There we go. Uh, this is called list comprehension. Essentially, what I just did is I used a for loop in one line. So to create range without having to hard code the numbers 2 to 14, I could do some quick code in here. I see David just staring at the screen like, yo, what? Uh, but essentially, I did a for loop here. X for X in range of 2 to 15, which really is just shorthand for a for loop. So I filled up the ranks in here. And then next I can do is going to be deck is equal to um and I could say, how do we do this? Actually, it'll get too complex. I'm not really good with this one. We'll just iterate through here. We'll say deck is equal to an empty list, and we'll go through our suit for suit in suit deck dot append. And we also need the ranks actually, so we'll say for rank and ranks, and we're going to append the suit in here, comma rank. Take that append, and this needs to be indented. And now we can print out deck and see what it gives me. And I see spade of 2 or 2. Let's switch this around. Actually, I don't like that format. Rank, comma, suit. 2 of spades, 3 of spades, 4 of spades goes on to 14, and then 2 of clubs, 3 of clubs, so on and so forth. I could spell out spade, club, heart, and so on and so forth. I don't really need it, so that's okay. But here's my tuple, right? I got a list of tuples here, each representing a individual card. Uh, I could print out the length of this deck to see how long it is. And I see here it's 52 cards, so I know I have a complete deck. Um, Additionally, yeah, I think it's pretty good. Do you have any questions of how I create this deck? Ask away, please, if you have any questions. I'm gonna put this inside of a function. That way I can create multiple decks if I needed to. I won't, but it's just I like having it in a function, and even I do need it. Um,
So then to call that function, you just print create deck, right?
yeah. I'll make sure you save it to a variable because this will create it and then return it for you. So I'm gonna create a variable called deck, which is going to use the create deck function. And when the function runs, it'll return the deck and assign it to the variable called deck. Right. And then I can just print it out afterwards. And there you go. Right. And then I can do something like deck 1, deck 2, and then deck 3, so on and so forth. And each one will be a unique deck. Yes, Jason.
I got a quick question for line 4.
Sure.
The ranks equals x for x. Will it still work if you remove the first x?
No. The first X is supposed to be like the result. Um, it's kind of how it's working. We could do something. I think I can do it here. Let's see if I can. I don't mess around with this too much, so I'm really bad with list comprehension. But I could say something like, I believe X comma Y for how do I do this? For X, and I'll see how I do it. But you can nest both of these together in one line and come up with decks. I don't do it often, but it does look pretty cool. It's very elegant. But it always confuses me, so I try to stay away from it. But it is a way to do list comprehension. I usually stick to only one-liners like this because it's easier and it's cleaner. But once you start nesting, it can get very confusing. But yeah, so X is supposed to be like the return value, and you say for X in range of 2 to 15, right?
Thank you.
Yeah, no problem. Any other questions? Awesome. So I have my deck. What is the next step?
Deal the hands.
Yeah, do a hand, right? So I can create a deck. Let's try to create a hand or deal a hand. We'll create a function called deal hand. And then this is gonna take a deck, right? And what else would it take in? I think
Make
that's
sure
about
you
it. You
make sure
what?
you assign deck above the function.
Where do you mean? You mean this?
Yeah, doesn't that have to be above the function since you're calling it into it?
I'm not calling in. This is a definition, right? The definition is different than when I'm calling the function,
Oh, never mind. You're
right?
right.
Down here, I would say deal hand, and I can pass in deck. Uh, but you know what? To not confuse you, and really, I shouldn't have done this. I should set a card deck. So these are two different things, so you don't get confused. Um, but yeah, this is me just setting the parameters of what it should be. And it should be able to take in a card deck. Why is it important for me to take in a card deck when dealing hands?
So it knows where to pull information or knows like what it's putting it into.
Should I deal hands to you, David, from a different deck that I dealt hands for Dante?
No, it makes it the standard input.
Right, right. So whenever I go to deal hands, I can pass in the deck I'm currently working on, to make sure that I'm only working with that specific deck. And I can kind of probably remove stuff within here from that deck as I go along. That way, I know what cards have been removed. But yeah, so I'll probably take in a deck here so I can update it as I give a deck to a player, or sorry, cards to a player. Now let's go ahead and create a player hand. We can say player hand is equal to I'll use a list for now. Maybe I want to add I might want to change the data structure later. I don't know. We'll keep it to a list right now until I see that I might need it in a different way. But with player hand here, let's go ahead and give them 5 random cards. We could say for I in range of 5, I would say. Because they should take 5 cards. We'll give them player hand out of pen. A random card from card deck. We could do something like card deck at index, and I'm probably gonna import random in here. Import random as R. Now give them a random number from 0 through 1 through 52. No, 0 through 51. Right? What's card deck? No, it's a dictionary, right? A dictionary. Is it create deck, return deck? No, my bad. It's a list. It's supposed to be a list. I confused myself by adding dict here. This is supposed to be a list, so this is fine. Index and then random index. Good. This is good. Let's go ahead and actually switch this up. I'm going to say random index is equal to that random number. Now passing this number in here instead, so I can hold on to this value, access a random card from this list of cards, add it to the player hands, and then I can say player hand dot I can say remover dot pop, and I will pass in random index. And it should be good from here.
Shouldn't you pop that from your card deck?
Player hat, yes, thank you for correcting my terminology. Card deck dot pop random index. And let's see how this works. I create the deck, and let's go ahead and I'm not gonna do anything crazy. I'm just gonna print out what player hand look like. So I'll run deal hand, I'll pass in deck, and then actually I want to print out deck as well to see what my deck looks like, or I'll print out the length really is what I care for. It should be like 47. If it worked. If I run this, I get 47.
You didn't
For
print
sure.
player hand. You just wrote player hand. 23.
Thank you for that, print player hand. Let's remove this print statement from deck so I don't get all that stuff. But I think it's working to a certain extent because I did see that printed out the length of that deck and it was 47. But here we go. So I see random numbers with random suits, right? Hearts, diamonds, clubs, spades, clubs, right? And the length of the deck has changed. So for sure, I know that I could create a hand that's unique, and I can at the same time update the deck, right? So far it's good.
Can
Do
you
I
real quick explain the on line 20, the definition of random index, like that R dot, like, what that means?
Yeah. So random is a library. Are you aware of that library?
Oh, I didn't realize you put import random as R. I didn't see that part.
Yeah.
Fine.
So when you import libraries or modules, you're able to give them an alias, right? Especially when the library has like a long number, long name, and you're gonna use this function pretty often. You can give it an alias, so you can say import random as R. That way, instead of typing out random, you can just say R, and it'll refer to the same thing. So
Gotcha.
R dot random. So it's still the random function. I just gave it a nickname, so I don't have to keep typing out its whole name. Do I have any other questions, guys? Awesome. So, yeah, I can view hands. I created a player hand, and I can return that player hand. So now that I got that deck, let's go ahead and do that. I'm gonna say player one is equal to deal hand, and I'm gonna pass in deck. And then let's do player two is equal to deal hand and pass in deck as well. And then it's finally print out player one and print out player two and make sure that they don't have duplicates. 13C, 13D. So no duplicate there. 6S, 6C, no duplicate. It looks good so far. I got an issue when I ran it the second time. Player pen. List index out of range. Okay. What happened?
You
This
didn't
time
account
around.
for the length.
Yeah. So this time that I ran it, I didn't take into account what happens if, let's say, for example, I run this and I get the number of like 51 or 52, which there should have been 52. I messed that up. and it lands on 52. So I add that 52nd card to the hand, and then I remove it. And then let's say the next item I get is also 52.
Not accessible anymore.
Not accessible. So I have to take into account that the length of my deck is going to change. So instead of giving the random function up to 51 or 52, let's say the length of card deck. That way, every time that it runs this for loop, it's going to take the current length of that card deck. The first time it runs, it'll be 52. But the second time it runs, it'll be 51. And then it'll be 50. And so on and so forth. So that way, every time I get a random number, it's going to take into account that my card deck is shrinking.
Quick question, Robert. Since that's a list, could you use random dot choice and just pull a random item out of that list?
Sure.
I mean, it would probably do the same thing.
I've never used dot choice. I saw you guys use it. I didn't. I've never used it. I mean, if it chooses a random number, then sure. But random gives you a random number as well. If dot choice takes an iterable and gives you a random one from in there, then that works too. Same thing, right? In coding, you're gonna have you're gonna be able to do the same thing with different ways. So there's no right or wrong answer. But if it does the same thing, Andrew, then yeah, sure, why not? And here we go. We're able to run this over and over again. Ooh, I got an issue. Why I get so this doesn't work perfect every single time.
Are you
Sometimes
ever are
Did
you
you
ever
run out of cards?
Yeah, I was about to say, do you ever reset your deck?
it doesn't matter. Because I'm only creating two different hands, and every single time I run my file, deck is being recreated. Right? If I had a for loop and I ran this 20 times in one turn of me running my file, it would run out. Right? But this doesn't have.
What if it's the same random integer twice and it's because you're telling it the index location? So what if it pulls the same index location twice, but it's already been removed? So that index is no longer there.
Like I said, it shouldn't do that because we're passing the length of card deck. Right? So let's say the length of card deck is 52 when I run this the first time. I use that random index to add a card using that random index. And here I remove it from card deck. And then I go back around. Right, I go to the next iteration. I get a random index and I check once again the length of card deck. Well, the length of card deck changed, so I'm only grabbing that length.
So
Right.
even if it picked like index 2 twice in a row,
-1. I have to take into account. I believe I do have to take into account. If I have 1, 2, 3, I want to grab from index 0 to index 2.
That should be right because then the length would be 3.
Yeah, I think the index was messing me up here. That's why I was getting that out of index range. There we go, buddy. Hey, okay, it was the index. That was the issue. Right? This includes the number I passed in here. So if I say, hey, the length of card deck, well, what's the length of card deck? 3. Right? So this is going to do from index 0 to index 3, but there's no index 3. I only have index 2. Do you see the issue? So we have to take into account that the index numeration is offsetted, right? Because random is inclusive. It will include the stop points. Whereas indexing, we have to take into account that we are one number shifted to the left. And at the same time, when we use the length method, it's not counting indexing, it's counting how many items are in there. So you have to keep into account these different number variations. So we have to offset. Well, there we go. Now this should work. And as you saw here, I ran them multiple times. No issue. We are good to go. We got 17 minutes left. So let's go ahead and kind of finish this off here. We'll do one check. But we have two different hands here, right? Excuse me. We should be able to create more players as well. And they should all have their unique values. Player 3 is equal to deal hand, passing the same deck. Because there's 52 cards, we should be able to do this like 10 times. We should be able to have 10 players without running out of cards. If we wanted to. And all three of these should be unique. There should not be a single duplicate. But let's go ahead and move forward. So we have these player hands. Let's go ahead and do a check hand, right? So we have create deck, deal hand. Let's do check, define, check hand. And actually, a much better way of doing this. No, this is fine. Check hand. We'll pass in play P1, comma P2 to represent player 1 and player 2. So two different hands that you're going to be checking, right? And each one of these has a list as a hand with their items. So how do we check their hands and how do we compare? Well, there's a couple ways of doing this. It can get very complex. There's a lot of different variations. I recommend poker ranking hands. We start from the top. We'll do a handful. And as a matter of fact, I'm going to go ahead. I'm exceed past 9 p.m. if anyone wants to stay back and see a couple more of these. But I'll go as far as I can. And then we'll break off and whatnot. Because I know some people really want to understand how this is done. Bro. Images. Open. Imaging. There we go. Royal flush. I want to choose. I want to check if all the suits are the same, right? Okay, cool. Let's check the suits. We can do the suits first. And really, check hand should be able to use helper functions. Who knows what a helper function is?
Function in a
No
function.
idea.
Okay. So if I created a big function, which really is, we shouldn't have a big function like this, that checks every possible combination, this one function will be massive. So ideally, it's better if you break this apart into smaller individual functions. So check hand should be able to do something like check royal flush, check straight flush, check straight, check two of a kind, right? It should do something very similar to this, where each one of these checks are probably their own individual function. If not, I might have like 100 to like 150 lines of code trying to check every possible combination, right? So what if instead we break these into individual functions and then we use these functions within the check hand function, right? That's what we call a helper function. And I think that's a much more organized way of doing this. So let's go ahead and let's take care of the royal flush first. So let's say define royal flush. And this will take a player 1 and a player 2. And let's see, we can do something like we might want to iterate through players, or really, it shouldn't take two players. It should take one. It should take one hand and check if that hand is equal to a royal flush or not. Right? It shouldn't take both players because that's going to be check hands. The royal flush should just check one hand. Check hand would check all the possible hands for all these possible combinations, right? So we're essentially here, we're breaking this bigger problem into a smaller individual problem. It's a little bit more digestible. So let's just check for one solution with one hand. And then we'll do multiple solutions like that. And then finally, we'll bring all these different possible solutions into one big overall checker, which is check hand, right? So royal flush should check if if everything in the cards is the same in regards to suits. So let's go ahead and say something like same suit is equal to false. And we can say for I in range, or no, we'll say for card in P1. Or we won't even call it P1. It should just be a player. So we'll keep it number friendly. So for card and player hand or hand, we'll say hand. I emphasize naming conventions a lot because I want to make sure that we don't get confused. For card in hand, we can do something like suit is equal to, we'll leave it blank. And then as we iterate through every card, the first card we get will say if suit is equal to blank. If we have yet to see any suits, that means we're on the first card. That means suit should be equal to an empty string because we have not found anything in here. So if it's equal to an empty string, I'm going to say suit is equal to card. And then the suit is the second index, or really index 1 of that tuple, right? For example, if this is the hand we're iterating through, right? That's hand. And we do for card in hand, the first card will be this tuple. Tuple with two indexes, 0 and 1. Index 1 is the numerical value, and I'm sorry, index 0 is the numerical value, and index 1 is the suit. So if I want to see the suit, I need to do card of index 1. Right? We're only going to do that if the suit is an empty string. If it's not an empty string, that means it's already equal to either D, a C, or H, or an S. Right? If it's not equal to an empty string, that means it's already equal to whatever's here. So we should say if suit is equal to card at index 1, then we don't really need this. Return false. Or we return true. Okay, I think this should check this. Or actually, maybe we should still have this here. Let's have same suit is equal to false. We'll say same suit is okay. I think I got it working. So what are we doing here? For card in hand, what is a hand? We have 5D. Let's add two cards in here. We have 6D. Right? This is a hand with two cards. The first card we get, let's say it is 5D. We're going to check if suit is equal to an empty string. Well, it will equal an empty string because this is the first card that we are iterating through. So if it is equal to an empty string, what I'm going to do is I'm going to grab this card, right? And I'm going to grab index 1, which will be D, and I'm going to save it to suit. Right? So suit is going to equal to the letter D. That's if this is the first item. Well, let's say it's not the first item. Let's say it's the second or the third card I've encountered. That means there's already a suit saved in there. If there's a suit saved in there, that means we're probably on card 2 or card 3 or card 4 or card 5. So if we're on a separate card that's not the first one, we need to check, does the suit that's currently saved right now, does it equal the suit that we're iterating through right now or not? If it does not equal to it, then same suit is equal to false. Right? Or actually, we might want to change this logic. Let's say if it's equal to it, we'll set it to true. Or something along these terms, right? What do you guys think?
You still need that last same suit equals true then?
No, that might have to be false. I want to make sure I get this right. Let's try it out, actually.
Couldn't you set your first value to the first value of hand automatically and then do for range from 1 to the end, and then that way you always have that value started there?
Yes. Let's do this. Return same suit. If it's equal to,
Shouldn't that same suit equals true be tabbed in as an else statement under that last if?
I think we'll start it as true. The moment we get to, let's say, return same suit. The moment we find one that's not equal to it, we'll set it to false. At the end, we'll do return true. Let's go ahead and print royal flush. Let's try it out before we do anything like this. And I will pass in within here. I'm gonna pass in a list. And let's change
Using that
this.
to like test it.
Yeah, I'm gonna test it real quick just to make sure that this is working, right? Let's check in the same suit because I'm starting to confuse myself. Create deck. We need to move some of these things above. Let's get rid of some of this stuff. Okay. There we go. Okay. I'm getting true here. Let's change this to like the C. And it gives me false. Let's get this to C. False. Let's change this to D. This one to D. Again. True. C. False. I think it's working. C.
Couldn't we actually turn this into another helper function that just counts the number of
Get out
matching
of my brain.
suits?
Get out of my brain, Thomas. I was thinking the same thing too, because we might have to check the suit for multiple different possible solutions, right? Let's look at the poker ranking hands. Same suit, same suit, same suit, right? Could we use a function to check the same suit for a hand? Hell yeah. Right? So why not do that? We could definitely do that. And that's a great point that you just made. We could definitely do that where we can make something like define same suit function, right? And as we already saw here, it's supposed to take in a hand that we're going to iterate through. And then let's grab all of this and just pass it in here. Because we might have multiple functions that do this here. And now this function royal flush, same suit is equal to same suit. Oh, I don't want to, is same suit. I don't want to call it the same thing. And I'll just pass in the function and then throw in hand in here.
Side question, can you have a set of tuples? And if so, will it consider both values in the tuple?
What do you mean?
Like, for example, if we were to do this, do a count and say like it grabs, the suit and then it gives you count of that suit and we put it into a tuple or something to where it gives us the suit and then the count number. If we put that into a set, say like hearts, and there's 2 hearts, as it's going through, like
Yes.
if it,
Yes.
okay,
I'm gonna stop you there, Thomas, only because there are so many ways to do this. Absolutely. Right? Absolutely. There are so many ways that you can check if something is equal to each other. Right? You can create a counter, check the first item, and see that first item by the end of this is equal to the length of the list. There's a lot of ways that you could do this. You could just use the count function to count the very first thing. Absolutely. Whichever method you decide to go with is gonna be up to you. Right? But overall, it should equal to the same thing. The same thing. But let's go ahead and finish this off here because it's already 9. Really, the only thing that was left here, guys, is after we check if it's the same suit, the next step would be to check the numbers, right? If I'm checking for a royal flush, what range do the numbers have to be? For card in hand, if card index 0 is less than 0 or less than 10, right? Return false. And at the end of this, we can say if same suit is equal to true, return true. Right? Because for a card in hand, we can return false. If this never returned false, that means every card we had was of value 10 and higher. We know there's no duplicates already. So we know this is a 10, jack, queen, king, and an ace, at least. So if this never returned false, then we know it's above a 10. So if this is true, and if same suit is true, then we could just return true.
Is that necessarily true if it's not sorted? Just
What do you
because
mean it's not
10,
sorted?
just because 10, like the hand is not necessarily sorted in numerical order.
Doesn't matter.
So like, couldn't any of the indexes be less than 10 would return that false? Not just
Why?
indexes.
We should, if we don't have a card that's great, that's 10 or greater, then that means this isn't a royal flush, so we don't care for it. So this royal flush function should return false.
Oh, never mind. I wasn't really reading the for card in hand part. Okay. Yeah, it's gonna iterate through each card. Never mind.
Right. So there you go. That's your royal flush checker. You check if it's all the same suit and if all the values are 10 or greater. That's all you have to check for. That's the only condition for a royal flush. Right? Checking the value of that card, if it's 10 or greater, 10, jack, queen, king, or ace, which we already identified as 11, 12, 13, 14. Right? It has to be greater than 10, and it has to be the same suit. Simple as that. You pass any hand, if it doesn't meet those criteria, it's not a royal flush. Right? And then you can replicate this type of functionality to everything else. Check if the values are in ascending order. Here, it won't really matter where the value starts. You want to make sure that you sort the list and it's in ascending order, right? Incrementing by 1. And then you can use the if same suit function here to check that. Here, you want to check that every index 0 is the same. And there's 4 of them, as well as the fact that each suit needs to be different, right? So it's just a bunch of if-else statements, less than or greater than. That's it. But with that, guys, I'm gonna go ahead and stop here because it is 9:03. We are above 10 minutes. That was essentially the poker function. The poker exercise. You guys did significantly better today than you did any of the last 2 days this week. I visually see the improvement, so that's awesome work. I want to just acknowledge you guys real quickly for that. I can visually see the improvement in your coding, so that's absolutely awesome. But without further ado, I just want to say congratulations for making it to the end of our course. That's going to conclude Intro to Coding Live. Today was the last day. There is nothing else that I have to teach you guys. Everything that you have gone over is everything that you need to be successful in the live technical assessment. You guys are good to go. You guys should be working on your part 2 application. If it's not completed yet, you should be close to completing it, or at least in the process of working on the exercises. You guys have everything that you need to be successful. Do not feel rushed. You don't have to complete your part 2 application yet. Just make sure that you do it before the deadline. So you can hold off on it and keep working on it. Tamika, thank you. I appreciate your kind words, and I hope to see you guys very soon. But I am still around, although I might not be officially teaching the class, throughout the week. I'm still the pre-course lead instructor. So if you guys have any questions, right? I teach all the pre-courses. So Intro to Coding Live. I'm in charge of the self-paced courses that we're currently building right now as well. And I'm in charge of foundation programming. My whole job is to help you guys make it into our full-time courses. So I am the person to reach out to if you guys have anything at all. But besides that, thank you all for showing up. I appreciate you guys who've shown up for the most part. If you guys recall, we started with a good amount of people, around 30 people, and today we had 11 show up. So usually, not to say that your attendance is a direct reflection of your acceptance rate, but usually those that show up are the ones that are going to be the ones that actually make it to our courses. Could be that you guys are the people that are actually taking the time to learn, right? You guys are asking the questions, you're putting the miles behind your keyboard, and you guys are showing that you guys have that commitment, right? And really, at the end of the day, even if you struggle with coding, if you show up every single day, that it's worth a lot more. So, more than likely, the people to your left, to your right now, and within this Zoom room, are probably gonna be the people who will be in your courses with you. Um, so thank you guys for showing up. I appreciate it. Thank you guys for being very cooperative and receptive to the information. I appreciate all the questions and you guys, coming off camera to talk to me. It helps teach this course a lot easier. But that's all I got for you guys. Thank you very much. I will stay back for a couple more minutes if anyone has any questions. But besides that, y'all have a good night.